into integrals. We are solving every integral from section 4, Roman 1 through section 6, Roman 2. Integral 4 Roman 1 shows 2x minus 3 over x squared plus 3x minus 18. We notice the derivative of the denominator is 2x plus 3, so we rewrite the numerator accordingly. Then we split the integral into the derivative part and a constant part that needs partial fractions. Finally, we simplify the partial fraction piece and combine everything. Next is integral 4 Roman 2, with x minus 1 over the product, x minus 2 times x minus 3. We set up partial fractions and solve for constants. The decomposition gives constants negative 1 over x minus 2 and 2 over x minus 3. Finally, integrate each logarithmic piece. Integral 4 Roman 3 uses the derivative approach. We express 3x minus 2 as 3 halves times the derivative of the denominator plus 4. This gives a logarithmic part and a tangent inverse part. When we split the integral, we conclude with 3 halves times the natural log plus 4 times the inverse tangent. Integral 4 Roman 4 again rewrites the numerator in terms of a derivative plus a constant. The constant part leads to an inverse tangent expression after completing the square. We finish with 3/4 times the logarithm plus root 5 over 2 times the inverse tangent. Integral 4 Roman 5 uses partial fractions because the denominator factors into x plus 5 times x minus 1. We find constants 19/6 and negative 1/6 and integrate the logarithms. Integral 4 Roman 6 again factors the denominator as x plus 8 times x minus 2. After partial fractions, we integrate to get positive logarithms with constants 33/10 and 17/10. Integral 5 Roman 1 has a square root denominator, so we express the numerator as half of the derivative plus minus 2. This yields a square root plus a logarithm after we use the substitution for x squared plus 4x plus 5. Integral 5 Roman 2 involves a negative quadratic under the root. We match the numerator to the derivative and subtract a constant to create a square root term plus an arcsine term. The final expression is negative the square root plus arcsine of x plus 2 over 3. Integral 5 Roman 3 also features a radical with a negative quadratic. We reorganize the numerator to include the derivative and a constant, yielding a square root term and an arcsine term with a scaled argument. The final result is negative 2 times the square root minus 9 times arcsine of 2x plus 1 over square root 5. Integral 5 Roman 4 uses the derivative of the quadratic plus a constant. The derivative piece gives half the square root and the constant piece integrates to a logarithm. Integral 5 Roman 5 rewrites the numerator so that the derivative produces a constant and the leftover is an inverse log. This yields 5 times the square root minus 7 times the natural log of x plus 2 plus the square root. Integral 5 Roman 6 writes the numerator as 3/8 times the derivative plus 7/4. This gives 3/4 times the square root plus a logarithmic correction with a constant factor of 7 over 32. Integral 6 Roman 1 requires a substitution. T equals the square root of x plus 2. We convert everything in terms of t and integrate a rational function. This simplifies to the natural log of the ratio of t minus 1 over t plus 1, which translates back to the square root expression. Integral 6 Roman 2 uses the substitution. T equals the square root of 4x plus 5. We integrate 1 over t squared plus 1 to get the inverse tangent. Therefore, the result is the inverse tangent of the square root expression plus constant. Every integral from 4i through 6(2) uses a blend of derivative recognition, partial fractions, and substitutions. This toolbox keeps integrals manageable and builds intuition for more advanced techniques.